Hello everyone, this is Nikhila Tippannawar from Arihant Arts, Commerce and Science Junior College, Bowdhan. Today in this video we are going to learn a new topic named coordination compounds. We will see what is meant by coordination compound, types of ligands, the terms used in coordination chemistry and Werner theory of coordination complexes. First we will start with what is meant by coordination compound. A coordination compound consists of a central metal atom or ion surrounded by atoms or molecules. For example, cisplatin, which is a chemotherapy drug, is a coordination compound in which the central platinum metal ion is surrounded by two ammonia molecules and two chloride ions, platinum NH3 twice Cl2. The species surrounding the central metal atom or ion are called ligands. So here NH3 and Cl both are ligands. The ligands are linked directly to central metal ion through coordinate bonds. A formation of coordinate bond occurs when the shared electron pair is contributed by ligands. A coordinate bond is conveniently represented by an arrow, where the arrowhead points to electron acceptor. The central metal atom or ion, usually an electron deficient species, it accepts an electron pair, while the ligand serves as an electron donors. Coordination compounds having a metal ion in the center are common. In cisplatin, two ammonia molecules and two chloride ligands utilize their lone pairs of electrons to form bonds with platinum 2. The donor nitrogen and chlorine atoms of the ligands are directly attached to and form bonds with platinum. Lewis acid and Lewis bases. Formation of a coordination compound can be looked upon as Lewis acid-base interaction. The ligand being electron pair donors are known as Lewis bases, and the central metal ion being electron pair acceptor, it serves as a Lewis acid. Now we will see what are the types of ligands or how we can classify the ligands. The ligands can be classified as monodentate, polydentate, depending on the number of electron donor atoms they have. What is meant by monodentate ligand? A monodentate ligand is the one where a single donor atom shares an electron pair to form a coordinate bond with the central metal ion. For example, the ligands chlorine, OH or CN attached to metal have electron pair on chlorine, oxygen and nitrogen respectively, which are donor atoms. Next is polydentate ligand. A polydentate ligand has two or more donor atoms linked to the central metal ion. For example, ethylene diamine and oxalate ion. Each of these ligands possesses two donor atoms. These are bidentate ligands. In this example of ethylene diamine, it binds to metal using electron pair on each of its two nitrogen. So it is a bidentate ligand. Similarly, the oxalate ion utilizes electron pair on each of its negatively charged oxygen atoms upon linking with the metal. Next, ethylene diamine tetraacetate ion EDTA4- binds to metal ion by electron pair of 4 oxygen and 2 nitrogen atoms. It is a hexadentate ligand. Because 4 oxygen and 2 nitrogen atoms are involved, so it is a hexadentate ligand. Next is ambidentate ligand. What is meant by ambidentate ligand? The ligand which have two donor atoms and use the electron pair of either of the donor atoms to form a coordinate bond with the metal ion. They are known as ambidentate ligand. See this example. In this example, the ligand NO2 links to metal ion through nitrogen or oxygen. The metal link through nitrogen and metal link through oxygen, both are shown. So it is an ambidentate ligand. Similarly, SCN has two donor atoms, nitrogen and sulfur, either of which links to metal, as shown in this figure, M arrow SCN or M arrow NCS. So both sulfur or nitrogen can be linked to metal atom. So it is an ambidentate ligand. Now we will see the different terms used in coordination chemistry. The first we will see coordination sphere. The central metal ion and ligands links to it are enclosed in a square bracket. This is called a coordination sphere, which is discrete structural unit. When the coordination sphere comprising central metal ion and the surrounding ligands together carry a net charge, it is called a complex ion. The ionizable group shown outside the bracket are the counter ions. For example, the compound K4FeCN6. It has FeCN4- coordination sphere with the ionizable K plus ions representing counter ions. This compound will ionize as below: K4FeCN6 giving 4K plus and FeCN6 4-. So in this, the ionizable groups shown outside the bracket, they are called as counter ions. Second, we will see the charge number of complex ion and oxidation state of metal ion. How to calculate the oxidation state of metal ion in a complex ion? The net charge residing on the complex ion is its charge number. It is the algebraic sum of charges carried by the metal ion and the ligands. The charge carried by the metal ion is its oxidation state. In this complex FeCN4-, it has charge number of -4. It can be utilized to calculate oxidation state of ion. Thus, charge number of complex is equal to -4. So oxidation state of Fe plus charge of ligands, it gives is equal to -4. So we have to calculate oxidation state of Fe. Oxidation state of Fe plus 6 into charge of Cn ion. Cn atom carries -1 charge, so 6 Cn, so it will be 6 into -1. So oxidation state of Fe plus 6 into -1, that is -6. So we have -4 on another side, -4 plus 6. So oxidation state of ion will be +2 in case of FeCN4- complex. Next is coordination number of central metal ion. Coordination number of metal ion in a complex is the number of ligand donor atoms directly attached to it, or the number of electron pairs involved in a coordinate bond. Look at this complex: cobalt NH3 4Cl2 plus. Here 4 ammonia molecules and 2 chloride ions, that is total 6 ligands, are attached to the cobalt ion. All these are monodentate. Since each has only one donor atom, there are 6 donor atoms in this complex. Please look at this complex: cobalt NH3 4Cl2, 4 ammonia and 2 chloride atoms, so total 6 ligands. All the 6, they are monodentate, as they are only one donor atom. Therefore, There are 6 donor atoms in this complex, therefore the coordination number of cobalt 3 plus ion in this complex is 6. Thus the coordination number of metal ion attached to monodentate ligand is equal to the number of ligands bound to it. Suppose consider the bidentate ligand C2O4 2- or ethylene diamine in the complex Fe2C2O4 thrice and cobalt ethylene diamine thrice 3 plus have 3 bidentate ligands. The total donor atoms in 3 of ligands is 6 and the coordination number of Fe3 plus and cobalt 3 plus in these complexes is 6. As they are bidentate ligand, they are in proportion of 3. So 3 into 2, 6. So total donor atom 6. Therefore coordination number for the metal ion is 6. Next we will see the double salt and coordination complex. Combination of two or more stable compounds in stoichiometric ratio can give two types of substances, namely double salt and coordination complex. What is meant by double salt? A double salt dissociates in water completely into simple ions. For example, Mohr's salt. FeSO4 NH4 twice SO4 6H2O. It dissociates in water completely, giving Fe2 plus 2 NH4 aqueous plus 2 SO4 2-. Coordination complex. A coordination complex dissociates in water with at least one complex ion. For example, if we take K4FeCN6, it dissociates in water as the complex ion and counter ion. So 4K plus aqueous plus FeCN6 4-. Now we will see a Werner theory of coordination complexes. The first attempt to explain nature of bonding in coordination compounds was put forth by Werner. The postulates of Werner theory, they are as follows. Postulate number 1. Unlike metal salts, the metal in a complex possesses two types of valencies, primary or ionizable valency and secondary or non-ionizable valency. Postulate 2. The ionizable sphere consists of entities which satisfy the primary valency of the metal. Primary valencies are generally satisfied by anions. Postulate 3. The secondary coordination sphere consists of entities which satisfy the secondary valencies and they are non-ionizable. The secondary valencies for a metal ion are fixed and satisfied by either anions or neutral ligands. Number of secondary valencies is equal to the coordination number. Another postulate, the secondary valencies have a fixed spatial arrangement around the metal ion. Two spheres of attraction in the complex. Look at this complex CONH36Cl3. It is shown the secondary sphere and primary sphere. A complex with coordination number of 6, it has octahedral structure. Look at this, in coordination sphere or secondary sphere, there are ammonia molecules, 6 ammonia, they are in coordination sphere, and Cl3, which is written outside the square bracket, it is in primary sphere or ionization sphere. A complex with coordination number of 6 has octahedral structure where the 4 coordinated groups are attached to the metal ion in the complex would be a square planar or tetrahedral structure. Now we will see the classification of complexes. The coordination complexes are classified according to types of ligands and sign of charge on the complex ion. Classification based on the types of ligands. There are two types of ligands, homoleptic and heteroleptic. What is homoleptic complex? A homoleptic complex. Consider CONH3 Here only one type of ligand surrounds the cobalt 3 plus ion. The complexes in which metal ion is bound to only one type of ligand is known as homoleptic. And what is heteroleptic? Look at the complex CONH3 4Cl2 plus. There are two types of ligands, NH3 and Cl, attached to cobalt 3 plus ion. In such complexes in which metal ion is surrounded by more than one type of ligand, it is known as heteroleptic complex. We can classify on the basis of charge on the complex. So now we will see the classification based on charge on the complex. One is cationic complex. A positively charged coordination sphere or a coordination compound having a positively charged coordination sphere is called cationic sphere complex. Look at this example. Zn NH3 2 plus and cobalt NH3 Cl SO4. These are cationic complexes. The latter has coordination sphere CONH3 Cl2 plus. The anion SO4 2 minus makes it electrically neutral. Next is anionic sphere complex. A negatively charged coordination sphere or a coordination compound having negatively charged coordination sphere is called anionic sphere complex. For example, nickel CN4 2 minus and K3 FeCN6 have anionic coordination sphere. FeCN6 3 minus and 3 K plus ions make the latter electrically neutral. Next is neutral sphere complex. A neutral coordination complex does not possess cationic or anionic sphere. Platinum NH3 twice Cl2 or nickel CO4 have neither cation nor anion but are neutral sphere complex. That's all. Thank you everyone.